In episode 53, titled Configure Firewalls, WAFs, and Core Security Services, we treat perimeter and service controls as precise allow lists, not broad suggestions that should work if the stars align. The stance is unapologetically strict. Name exactly which conversations are permitted, on which ports, between which identities, and prove that everything else is denied by default. This approach reduces guesswork during incidents and transforms tuning from folklore into evidence-driven decisions. As we move, we will stitch together stateful filtering, web application protections, name resolution safety, and outbound governance, so the edge becomes a dependable enforcement point rather than a busy thoroughfare. By the end, you should be able to explain every permit in a sentence, every deny with a reason, and every exception with an expiration and an owner. Stateful filtering does the heavy lifting at zone boundaries, but only if you configure it with the same specificity you expect from humans. Identify the talking parties by network, tag, or service identity, not by a sprawling list of ad hoc addresses. Lock the destination to the real service port and verify the protocol with application identification to catch protocol smuggling. Track session state so replies are allowed based on established conversations, not on mirrored return rules that expand blast radius. Include explicit denies for dangerous combinations so your logs show intent rather than silence. And tune timeouts to match the application's behavior so you neither starve long-lived sessions nor keep zombie flows alive. What you gain is a boundary that knows who started a conversation, why it persists, and when it must end. Name resolution is an overlooked control surface, so treat domain name system, or DNS, security and egress shaping as first-class citizens. Point clients and servers to safe resolvers you operate or trust. Enable logging that ties queries to authenticated sources, and block lookups for newly observed or known malicious domains. Deny direct DNS to the Internet except from resolvers, and consider DNS over TLS or DNS over HTTPS from endpoints only when you can still observe and govern destinations. Pair resolution controls with egress rules that stop command and control patterns, regular low-volume beacons, domain generation algorithm lookups, and suspicious tunneling labels, so adversaries cannot silently navigate. The story you want to tell is simple. Only known resolvers ask questions, only permitted hosts reach out, and you can reconstruct who resolved what and when. Outbound policy is where many programs drift, so harden it with least privileged destinations and, where appropriate, proxy inspection that understands protocols. Replace allow any to the Internet with a short, named set of destinations that match business needs, update services, partner endpoints, content delivery networks, and public application programming interfaces documented by team and purpose. For Hypertext Transfer Protocol and HTTPS, funnel traffic through proxies that validate certificates, enforce cipher and version baselines, and record request metadata without leaking secrets. For non-web egress, justify each protocol's presence and verify it with flow logs and packet samples. When outbound is precise, your incident responders inherit a clean map of what should happen and can escalate any deviation from normal into a high-signal lead. Administrative access deserves its own corridor, not a shortcut through production paths. Segment administrator reach behind jump hosts that record sessions, require multi-factor checks, and terminate mutual transport layer security, or MTLS, so devices and administrators both prove identity. On network devices, use per-command authorization, often through Terminal Access Controller Access Control System, to ensure only intended commands execute, and log every decision with parameters. Prohibit direct management from user subnets, and disable management services on data interfaces wherever a dedicated management plane exists. This pattern shrinks the space where a stolen credential can operate and leaves a trail that explains who changed what, where, and why. Intrusion prevention earns its keep when it is selective and tuned, not when it floods dashboards with brittle signatures. Enable high-confidence signatures that reflect real exploitation attempts against services you expose, and couple them with behavioral detections that watch for anomalies such as protocol violations, cross-protocol tunneling, and impossible handshake sequences. Place prevention inline only where you can tolerate occasional false positives, and favor detect only in paths where availability is paramount until rules are proven. Regularly cull unused or noisy signatures and upgrade engines so evasion tricks do not sail past. The aim is not maximum coverage, it is maximum credible blocking with minimum collateral damage, backed by metrics that show prevented harm. Rule lifecycle automation prevents the slow creep from clean edge to museum of exemptions. Build a workflow where requests are submitted in plain language, reviewed by peers, approved with a ticket, implemented by code, and given an explicit expiration. When the clock runs out, the rule retires unless renewed with fresh justification. Send reminders before expiry, archive artifacts with the change, and publish a weekly digest of adds, modifies, and removes so everyone understands the pace and purpose of change. Over time, this rhythm makes the edge safer and the culture calmer because nobody has to hunt through comment-free configurations to figure out why port 81 is open to a mystery subnet. Validation converts configurations into facts you can rely on. Linting catches syntax errors and style drift before changes hit the fabric. Shadow rule checks detect useless permits or denies masked by earlier, broader entries. And pre-deployment simulations show whether the proposed rule set behaves as intended for representative traffic. Add packet capture tests at boundaries and replay a small library of expected and forbidden flows to confirm the enforcement path. Treat failed simulations as learning opportunities, not political events, and make fixes in the same code review that surfaced the issue. When validation is normal, production feels less like a cliff and more like a curb. Monitoring tells you whether your rules are paying rent. Hit counts highlight which allows earn their keep and which have gone stale. Blocked attack counters show where virtual patches or signatures are carrying the load. And top talkers reveal unexpected bandwidth hogs or new dependencies that deserve design attention. Correlate these metrics with change calendars and incidents so you can attribute shifts to causes rather than chasing noise. Publish short, regular notes summarizing the 3 most interesting changes in edge behavior, and tie each to either a rule update, an application deployment, or an emerging threat. The result is a feedback loop that keeps both operations and security grounded in observable reality. Pitfalls accumulate in every estate, and you fix them systematically rather than heroically. Overlapping rules create ambiguity and mask intent, so collapse them into a single, readable allow with a clear comment. Disabled protections, like a WAF rule turned off during a rush, must be tracked with owners and end dates, then re-enabled or replaced after the pressure passes. Logging gaps hide both success and failure, so ensure every boundary emits records with source, destination, action, rule identifier, and reason. Attach each remediation to a ticket and a diff so historians, auditors, and new teammates can follow the journey from problem to durable fix without spelunking. A crisp operational scenario shows how these pieces work under stress. Imagine a high-risk vulnerability drops for your public application framework. Within minutes, your WAF vendor publishes an emergent rule set that matches the exploit's request shape. You enable a virtual patch in block mode at the edge while developers prepare code changes. You raise targeted rate limits for the sensitive endpoints to blunt probing and add a temporary identity requirement for administrative paths. Meanwhile, you stage a rollback, a canary rule package that disables only the emergent rules and a timed fallback if error codes spike beyond a threshold. Throughout, you capture metrics, blocked attempts per minute, error rates, latencies, and source distribution, and attach them to the change record. When the patched build deploys and tests pass, you remove the virtual patch or keep it in detect mode as an early warning. We will close with a concrete cadence that keeps edges clean. Over the next 30 days, schedule a focused rule review to retire low-value or stale entries, starting with permits that see no hits or that serve decommissioned systems. Replace vague descriptions with plain sentences that pair each allow to a business purpose, an owner, and a review date. Confirm that temporary exceptions have expirations and that monitoring alarms will fire if they linger. When the month ends, you should have fewer rules, tighter intent, and clearer evidence, an edge that behaves like a precise allow list rather than a scrapbook of past emergencies. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.